Good evening, everyone. How do you feel? Yeah. First and foremost, thank you so much that you managed to come here, that you decided to spend our evening together with TechSpot. I welcome people who are watching us online. That's very much appreciated, and I hope that you also gonna like today's event. But the first thing, the biggest shout out to the organizer, to On the Spot, and let's make a round of applauses. Yeah. Uh, you might have a natural question. Who is it? Give me a time, I'll explain. Actually, On the Spot is a software company that builds R&D teams for tech startups, for big companies growing. And that's, for example, these are the startups that we've already built teams for here in Warsaw. And TechSpot, actually, these events is our way to learn, to be on the edge. For example, as you might have seen in today's program, we're hosting people that someone is building an outsourced tool, which is an alternative to Kubernetes for managing AI infrastructure. Someone is building a tool that is one of the most, or probably most, flexible tool for collaboration within a company. Somebody's building I don't know, one of the most emerging startups for pharmaceutical industry, which are our friends. And like, we invite these experts, and we're super happy to learn from them. And we are happy to share their knowledge and their insights with you. And of course, we're hiring. Don't hurry up. Take your phone, see our open positions. You might find something valuable and something just for you, because lots of open positions. Yeah, I'll give you some time. No rush. Okay. And one of the most important slides, of course, On the Spot helps us, but this all is organized by people. And I want you to ask another round of applauses for our volunteers, which organize everything here today. Yeah, thank you. Also, we got friends that supported us while promoting these events, and you might seen them on the screens all around Google Campus. And go and check their telegrams, join their communities. You might find like-minded people, lots of like-minded people there. What's an agenda today? We're gonna have talks. After the second most lovely time, the pizza arrives. And then we're gonna have another 2 talks. And in order to inspire and motivate you to talk, to be to ask questions, we got invitations to the after party. After the event, me, speakers, organizers, volunteers are going to after party. And of course, there is no bar in Warsaw that can host 200 people. So we give these invites for interesting questions. They are all here. So please be creative. Raise your hands when you want and ask a question. All the photos from the event, recordings, you may find in our LinkedIn. Please subscribe, see. Our photographer is beautiful. You're gonna have nice pictures over here. And that's probably it from my side. And I'm happy to invite on the stage the first 2 speakers. And the important thing, this event is something, I don't know, something miracle, because we have 4 talks. 3 of them will be run by 2 speakers. I believe that's something something nice about this event. So I welcome guys on the stage. Please meet developers from Fibery.
Hello, nice to see you here today. Let us introduce ourselves, who we are. My name is Vladimir Petrika. I'm developer in Fibery. I practice software engineering for almost 20 years. Also, I have additional education in machine learning. My graduation work was dedicated to generative text models. Before it was a hot topic as it is today. And this is Max.
Yeah, hello, thank you. My name is Max. It's a pleasure to be here. Recently, I finished master studies, mostly exploring intersection of fields of generative AI and unsupervised learning algorithms, like clustering. And I'll be talking a bit later about theoretical foundations of our features and why we decided to do one way and not the other. So, Vova, stage is yours.
Let's start. Our today's talk is called When AI Meets Flexibility. And here is our plan for this talk. We plan to give you some intuition about what Fibery is. Also, then we'll follow 10 minutes demo where we will use AI to set up interactive game with you. After that, we will listen Max, who will make a technical deep dive into Fibery AI implementation. And also, in parallel, you can take your time to continue play the game. And after that, we plan to close the game and award the winner. And after that, we will have a small QA session. So let's get started. What is Fibery? Raise your hand who knows what is Fibery or maybe heard something of it. Quite a lot, to be honest. So to continue, I have to give you some introduction. What is Fibery? Our marketing team states that Fibery is an operating system for a company. Our user champions told us that we make a flexible constructor for business processes. Our engineering team inside thinks that we made yet another flexible no-code tool. But what everyone agrees on is that Fibery is something flexible. But what is flexibility? How can we define it? Basically, Fibery business is built on idea that most business cases for small to medium business can be expressed as an open set of objects with special properties, and we call that objects databases. Don't be scared, here's some examples. For example, Scrum process for software development can be expressed in terms of release, story, bug, and sprint. Sales CRM, sales process can be expressed like a CRM with following set of objects like account, activity, opportunity, contact. But what makes Fibery databases so special? Actually, it is a set of properties these databases own. Here. Logically, they can be split into three parts. First part is schema, which defines data structure. It includes relations and primitive fields for structured data and rich text fields for unstructured data. Also, I must say that relations is very powerful property in Fibery because it allows to scale system and adapt data domain to a growing user needs. Then formulas and rules are actually behavioral properties. They force data structure to follow some rules. And finally, permissions and views, which basically a visualization. And visualization defines a bunch of ways to represent and manipulate specific data from a database. Permissions actually also very powerful property, but it is out of scope for today's talk. What can be visualization? Visualization is a set of such views like table, board, list, timeline, calendar, very powerful reports and charts. Also feed, map, document, whiteboard, and form. Also, plus to that, you have a possibility to chat with your data with custom chatbots. Let's imagine a situation when we make this property set weaker by throwing away relations, rich text fields, permissions, and leaving for visualization only basic charts and powerful tables. What do you think it is? I think that this is known product. You know it as Excel. So basically, Fibery takes this idea to the next level by adding some new dimensions to this property set and enabling on this data structure through multi-user collaboration. Fibery is powerful enough to interconnect all information in this organization and replace or in some way integrate data from different tools companies usually use for tasks like CRM, sales, product management, HR, and things like that. Our sales portfolio includes schools and educational organizations, laundries, churches, libraries, and even cannabis farms. So Fibery basically is very powerful and very flexible. Now let me show you how AI is integrated into such flexible system from the product perspective. We will try to create a game inside Fibery using AI help along the way. So 10 minutes adventure, in and out. Okay, game is the best way to learn something new. So we have two prizes for you. First prize, prize A and prize B. Each of one is actually a very cool book you want to see. One is old school and then very practical one. And I propose you to play a game called Guess Half of the Average. Rules are the following. I challenge everyone to guess a number between 1 and 100, such that the number is as close as possible to half of the average of all players' guesses. So player who make a closest guess and do it first will win. So I challenge you to think about strategy, because you should consider not only own strategies, but also guesses of others. Okay, let's come to setup. So we have two databases here, game database and the price database. What is missing here is a player database. We can make it manually, but let's challenge AI to do that for us. So let's do some prompt engineering. So we ask AI that we need players database. Then we state that player should be identified by email. Then we state that player's guess should be a number. And let's allow player to leave feedback. Then let's define that player participate in one game once. And Player can win one prize only. Let's generate. So what is proposed changes? Create new database with fields and some relations, many-to-one and one-to-one. Let's apply changes and see what's happening. So we see that player database is created. Okay. So we see a set of fields we asked to create: guest, feedback, email, and a pair of relations: relation to game, one-to-many, and relation to price, one-to-one. Let's go and add one player manually. Let's identify it by email. For example, test@fibery.io. And fill in some fields, like make some basic guess, fill in our game, and let's leave property price empty for a while. Then to enable everyone to play, we need special type of view called form, which actually represents our database. So we don't need price here, and let's reorder it a little bit. And go through fields. So email field should be required. Guess field also required. Let's make feedback optional. And the game property, let's make it hidden, but set up default value to our game. Then let's change response and wish a good luck. And of course, let's change a cover. Doing some repositioning. Cool. Let's create our first player via this form. So I enter my email, vova@fibery.io. I made some basic guess and leave some feedback. What a boring talk. Do you agree? Submit. So we see a new record which represents all our data we just entered. So we see that we have two guesses here, and average of these guesses is 50. But outcome of our game should be half of the average. So let's go and add a formula to a game database. Call it outcome, and ask AI to generate formula for us by the following prompt: half of the average of all players' guesses. It looks correct. So we see that outcome of 50 is 25, which seems correct. Okay, let's do another measure from the player perspective by adding new formula which define deviation of user guess, player guess. Let it be a square difference between user guess and game outcome. We use squared because it creates always positive value and greatly emphasize errors. So let's make it clear. So we display guess and display deviation here, and make some reordering. So now let's go and create another player who made another guess less than 50, for example, 25, and leave some feedback. Okay. So we see this record here, and we see that average of guesses has changed, and game outcome has changed also, and it becomes slower. So now let's go and add some behavior to our player database. And we need some protection, so let's kick cheaters off. This rule should be triggered on player created or player updated when email or guess properties are affected. And let's do it via script and ask AI to generate it for us. So here we describe our needs. Kick from the game players with duplicate email or guess, which is out of 100 range. So we got some results, and you see, just imagine you have to enter it manually. So you see, let's test our automation. You see, I made a mistake here, and if I remove this redundant dot, I will have a duplicated email, and this record should be kicked from the game, and it works. Let's test another rule and test guess more than 100. Kick it from the game. And another test for value less than 1. Kick it from the game. Cool. Let's get back this player to game because it has valid guess. And do something interesting. We go to our space and ask AI to create a view which show players out of any game. So we see it created a view for us, 2 familiar records, and this view is created using a filter. And if we disable this filter, we see all our records we have in our database. So let's back it, enable. And what is left is to make our form public. Let's share it to the web. Okay, and let the game begin. So you can start scan this URL, but also this QR code will be available during the following talk. And now let me invite Maxim.
Thank you. So, as I said, I'll delve deeper into theoretical parts of it. And now, as you saw a decent part of our AI capabilities in action, let's see how things work inside, starting from Fibery working components and how we can represent them. And it can mostly be done by either using text or bare JSON for unstructured or structured data. And both of these things can be easily generated using AI. So that's what we did. We essentially applied it for every component you can see here. And we used a common technique for this, as you may guess, which is called prompt engineering. Now, of course, prompts will look different depending on what kind of task you want to perform, whether you want to generate some text for rich text fields, or create relations and primitive fields, write better formulas, or create views. However, underlying implementation remains roughly the same. So I would like to take formulas as an example and show how we've implemented AI there. And a quick look onto formula UI creation. So here I ask our formulas AI to generate total spendings of a customer. So on the right side of the slide, you can see we have database customer with one-to-many relation to database order. And so essentially, I want to sum up prices of all the orders. And now from the point of view of the model, what it should get to be able to generate such a formula. It should get, of course, the name and description of my request, so what kind of formula I like. It should also get, in case of Fibery, related schema to my request. So what fields it can use in its answer, and what kind of relations it can use as well. And it will also get how to use our formula syntax. So we will provide AI rules it can apply. But coming up with such a formula first time is kind of hard for any model right now. And it's very common to give it some examples before actually asking a real request. And so for this, we have two common methods. The first one is called in-context learning. It is a fancy way of calling just giving a bunch of examples to the model. So as you can see here, I give it 2 examples and then asking a real request, hoping the model will get the pattern that is present in my examples and will use it for the final response. The second approach is to take pre-trained model and fine-tune it based on your data. So you collect these examples into a file and tailor the model to your needs. The main advantage of such approach is that then you don't have to use examples during inference. So the model already knows what it's supposed to do. And of course, it's a bit cheaper during inference time. However, performance of the two methods, in other words, quality of response of the model, remained roughly the same. So we decided to go for the first approach, which is in-context learning. And also, secondly, because we decided to generate examples dynamically based on incoming user schema. But I'll talk about it in a bit, because first, we thought we can get away with predefined set of examples. And particularly, we put them all into a single message and sent it to the model as it is, hoping it will understand what we mean. Turns out not to be the case. It doesn't really understand what it's supposed to do. So then we decided to split each example into a pair, where the first message is user request, and the second one is assistance response. And a quick reminder here, user requests contains formula name description and related schema. And so when we move on to examples themselves and how we've generated them, essentially we created 3 different domains in Fibery: DIY, local shop, and project management, to try to broaden model's view in examples on what kind of data it can face. And we created formulas ourselves, written some descriptions, and put them in as an examples to any user request that was coming in. We started to see problems with such approach right away. And the main one was that the model would take fields and relations from example schemas in its final response, and not from the user schema itself. So we thought we can get away with simply adding more examples. And so we kept testing our current set and adding more examples where the model failed. And we kept testing and adding more examples. And the sets basically started to inflate. And at some point, we end up with something like this. So yeah, we had to change something. And what we decided to do is to get rid completely of predefined set of examples and instead generate them dynamically based on incoming user schema. So how it works? We have the user schema in the request, which already contains fields and relations the model can use. And somewhere, we also store a list of example templates, which are relevant for different field types. And so each template here already has formula name, description, the formula itself. However, it does not have a field name yet. And this is a job of fitting function to take an example template, take a look at the user schema, and try to find fitting field. And if it finds one, it generates us an example. And so this approach, the main benefit of such approach is that we do not have to use any predefined schemas in examples that model always hallucinates about, and instead we focus only on user schema. Of course, it takes a bit longer, but it's still fine. And we saw a huge performance boost using this approach because now the model has nothing to hallucinate about. And that was prompt engineering in Fibery, and it is applied to every component you can see here. And while this technique is great for generating content, we needed a different AI technique to help user to find relevant information more easily. And that's where embeddings come in, and we use them for search and clustering in Fibery. So what are embeddings in the first place? Essentially, you have some text, and when you feed it through the large language model, you get an embedding. So from this diagram, you can think of embeddings as of vectors that try to represent semantic meaning behind the text. And that's very important because they do not simply encode the words they see, they try to look deeper into the meaning of the sentence you gave it. And if you do such thing many, many times, you end up with a vector space, or in this case, embedding vector space. And each point on this drawing here is a vector. And this space has a very nice property to it. And it goes as texts with similar meaning will end up close to each other. So if you try to embed dog and cat, they're both domesticated pets, they will be somewhere close. And texts that have completely different meanings will be far away. And this property is very important because now we can use this embedding space to search it. And although, a fun fact, we can perform mathematical operations on embeddings and get actually quite meaningful results. So if you take vector of France, so you embedded word France, and subtract vector of Paris from it, essentially you get like country without a capital. And then if you add Madrid to this country, you will land somewhere close to Spain in the embedding space. And so that's kind of fascinating to think about. And at the same time, this exact property of embeddings, ability to represent semantic meaning mathematically, is what makes them so powerful. And now, when we know the concept of embedding, we can move on to implementation and how we've done it in Fibery. And in our case, texts are written by the user himself. So suppose we have a database of tasks. Each task has name and description. And so this would be the text that we embed in Fibery. And before embedding, we will split each document, so each task, into smaller chunks. And this is very common in the field, and it is done in order to not to mix a lot of concepts in a single embedding. Because suppose you have problem written out in the task, solution to it, maybe some comments, etc. You don't want to mix it up. Embedding becomes too generic, and it contains too much meaning. So we split it into multiple chunks and embed them separately. And so that's the next step. We embed them. In our case, we use OpenAI. However, we already think in using something else, and store them in a table. And then, in order to make embeddings useful, in other words, search them, we have to also upload them to a vector database, because relational databases are not really fit for vector search. So that's the last step of our diagram. And I would like to delve a bit deeper into splitting and loading steps now, because for splitting, we decided to use 3 different strategies. The main reasoning behind it is that we wanted to capture context on different scales. So the first one is large, and we split text into huge chunks, 2,000 characters each. The second one is looking at the headings of the document and splits based on them. And these 2 will be applied to any text you upload to our vector database. And third is called paragraph, and it splits text into chunks of couple of paragraphs, which each chunk contains a couple of paragraphs. And this one we use mostly for clustering, which I will be talking about in a second. And now, when the whole text is split and embedded, we can upload it to vector database. In our case, it is Pinecone, and we've chosen it mainly for 3 reasons. The first one, it was very simple to set up because it's completely cloud. Secondly, it implements serverless architecture, which is, in other words, pay as you go, and you don't have to pay for resources you do not use, which saves us a little bit of cost. And thirdly, it allowed us to define metadata fields on embedding level. So if we already know what kind of embeddings we are looking for example, a certain type, we can narrow down the search right away. And that's the feature that not a lot of vector databases provided at the moment. So that's why mainly we decided to go for Pinecone. But all of these things, splitting text, embedding it, uploading to vector database, is done in order to improve user search experience. And so that's what happens when a real user query comes in. Maybe we are trying to look for some task. The first thing that happens in Fibery is we go to a keyword search engine. In our case, it is Elasticsearch, and under the hood it uses BM25. And that's like standard search that is present everywhere. Secondly, though, in parallel, we also go to semantic search. And so we embed user query first in order to obtain a vector, and then we query a vector database. And when both of these systems return some results, we mix them up. And we use a simplistic algorithm which is called reciprocal rank fusion, which is essentially an algorithm which is specifically designed for mixing results from multiple search systems. So that's how searching is implemented in Fibery. However, we realized that we can take it even further and use embeddings for clustering. And so what clustering means is grouping closely related text chunks, or embeddings in our case, together, which form a cluster. And a perfect use case for this is feedback. So suppose you have some feedback about your product, and you want to reveal most commonly requested features or some patterns that present in this data. And so clustering would be a great fit. And in our case, how it was implemented theoretically. We get an embedding table, which, as you remember, each entry here is simply some text chunk. And ideally, we would like to just apply clustering algorithm, maybe a bit more sophisticated one, like HDB-scan, and get some clusters right away. However, we figured out that this approach is too generic. And by too generic, I mean that we would get just a couple of clusters. They would be huge clusters, but they contain only like positive and negative feedback. So we had to encourage the pipeline to provide us a more specific clusters. And the first thing that we decided to do is get rid of irrelevant information. So in our case, definition of irrelevant would be text chunks. They don't carry any particular opinion about something. So reviews like I love Fibery would be filtered out. Although they are nice, they are not really specific. And reviews like your tables are fast are pretty good for clustering. And this is done via customly fine-tuned large language model. And during fine-tuning process, we figured out that we can categorize each embedding into one of the two categories. The first one is problems, and the second one is insights. The main reasoning behind this is to encourage clusters to be even more specific. So now we form clusters of problems and of insights. And extremely common step in the field of unsupervised learning and clustering in particular is to apply dimensionality reduction to embeddings. In other words, you try to shrink number of dimensions from a couple of thousands that usually embeddings have to just maybe 50 or 100. And although it was written in every literature that this step has to be applied because density-based algorithms don't really love high dimensions, and this is called cursive dimensionality, we found out that it gave us two generic clusters again. So all of this work that we've done to make clusters more specific was simply thrown out. So we decided against using it, and instead simply cluster problems and insights separately right away without applying any dimensionality reduction. And from practical point of view, how it was implemented, into words, we had 3 services. The main one is orchestrator, and 2 dedicated ones, classification and clustering. And the first one would accept the job request, start to pre-process the data. In our case, we removed punctuation, links, emails, all the stuff that is not needed for classification service. And then we wait until we classify each embedding into problem, insight, or none. So we filter it out. And a quick side note about classification service. As you remember, we fine-tuned a custom large language model, and we had to host it somewhere. And we decided to use RunPod for this, which is essentially a GPU cloud. And we chose this company specifically because they offered scale to zero feature, which shut down your GPU server when there are no requests for maybe 10 minutes. You can set this time on your own. And then it starts very quickly on the first request. And of course, when the server is down, you don't have to pay anything. And that saves us a lot of costs on hosting GPU, because unfortunately, there are not that many clustering requests yet. And once embeddings are classified, we can start cluster them. And here we also apply a little trick. We run multiple clusterings with different set of hyperparameters. And so set of hyperparameters basically controls how clusters form. And they can be set of these hyperparameters can be optimal for different kinds of data. So you have to cluster it many times in order to get the most optimal ones. And when we find these, and this algorithm is automated, we return the most optimal clusters back to orchestrator. Then we name each of these using GPT and basing on text chunks that got into the cluster. And then we create everything in Fibery for users to take a look at these. So entities, highlights, views, whatever is needed. But I think it was too much, and now it's time to go back to the demo. And let me show you very quickly how clustering is performed in Fibery. So here, let me go first to the setup. We collected approximately 3,000 reviews from Google Play about Twitter, now called X, and we would like to get some topics out of it. So we can cluster it, select review topic, and start. We can also select a date here. However, clustering usually takes from 10 to 20 minutes to complete, so I ran it before the presentation. And once it's done, you will get notification in your inbox, and if you click on it, you can see a table where each row is a topic that our algorithm was able to find. It already has some sentiment to it. And here you can see how many related fragments it has. And so the way to explore it is simply to click on it and see what users think about Twitter nowadays. Seems like they're not really happy. And so this way of viewing information is much more structured than just to go from feedback node to feedback node one by one. And on this, I would like to finish my talk and give a word to Vova, who will hopefully show you results of the game. Thank you.
I hope you enjoyed. Okay, let's first of all, let's close our game. So you have a last chance to make your guess. Everyone? Okay, let's. Okay. Where is it? Let's give people maybe from online also to make their guess. So we don't know what will be the outcome. All this happen live. 5, 4, 3, 2, 1. No more bets. Okay, let's close our form. Stop sharing. No more bets. And before we look on our winner, let's make one more thing. Let's see if AI is good enough to play this game too. I saw that some of you all try ChatGPT to make their guesses. But let's ask Fibery AI to do that for us. Let's go to our game and ask AI to make his guess. By the way, you have ability to create your own prompts and save them in Fibery. So this is quite interesting feature. Maybe you missed. Oh. Okay, I have to relog in. Sorry, guys. Because, no, just a second. Я сделаю публичный.
Least you know it's live.
Ну.
Он тебе подключен?
Угу. It should be final. So you can not only create your own prompts, but share it with the team. Here is it. We ask AI to make his guess. I made the prompt, special prompt, which explains how to play this game, and also ask AI to make his guess. So the idea is that if, for example, everyone in this audience make a guess 50, then half of the 50 will be 25. And if you're smart enough, you will think, okay, let's my guess be 25 better. So if everyone also smart enough, they also make a bet 25. And this, using this iterative strategy, you should come up to so-called Nash equilibrium, where the best guess should be minimal value available, which is, in our case, is 1. But this happens only if everyone in this audience is rational enough. So when you play, you should consider irrationality of your neighbors. So this game also used as a measure for community intelligence. So let's see, AI made a guess 13. And let's register it also. AI at Fibery.io. Okay. And before we proceed, let's see if we have some cheaters here. Yes, and we have a little bit. So guys, I warned you, this is Sparta. Let's see at distribution of all guesses. Distribution of our game. So let's update it. We see that average is almost 20, and half of the average is 10.41. And we have quite a lot of people here who was nearby. So let's go. And as I told you, we have a feature in Fibery. You can talk with your data. So let's go and ask AI assistant to show us top 10 players whose guess guess has minimal deviation. Let's see if it works. So we have some winners. Let's create a more comfortable view for this. And we see top 10 people who made a guess with minimal deviation, and minimal deviation is 0.2, and this is 𝐀𝐠𝐞𝐧𝐝𝐚. Is it here? So we give you a prize, and we send you an email using this button. You can then go and choose which book do you want, because one of them is really hard to read. So basically, this is it, guys. I hope you enjoyed this talk. Sorry? And second book will be for best question from the audience. So let's make some Q&A session now.
So, who's got a question? Please raise your hands. We need to make a mic. Yep. Mm-hmm.
Hi, I have a question about your custom fine-tuned LLM.
Yep.
Had you tried fine-tuning OpenAI models for this task?
Which task do you refer to exactly? Because
exactly
we tried. Prompt engineering one?
The clustering stuff.
Sorry?
Clustering stuff.
Oh, no, because it's too costful. It's much cheaper to just fine-tune it from Hugging Face, open source. And although, because we had to have a predefined set of labels, so what I did, I took LLM and put a classification head on top of it. So basically a feed-forward neural network and fine-tune it as it is. So
thank you.
Yeah.
Mm-hmm.
Thank you for the demo. Maybe stupid question. Did you consider to buy some GPUs and just put it to your rack and by this just save cloud costs?
To our private servers, you mean?
Yeah.
For all the other stuff, we used Kubernetes, and we calculated that it will be more costful to host on Kubernetes. So we are looking for another provider.
Oh, hold on.
Yeah, hi. So basically, you ask model to generate some code, yeah? Like code for your platform, for the constraints and so on.
Yeah. Essentially, it generates JSONs.
Okay. So how do you validate that this code it will actually work? So basically,
we try to run it.
Okay,
so we apply it first, like in demo, you can say way. If it succeeds, we present it to the user, and if user approves this, we apply these changes like hard.
And if it's not working?
You will get an error. That our AI is not smart enough.
Okay, so you do not regenerate it, no?
We tried a couple of times, because models can hallucinate and all of this stuff. We tried a couple of times, and we have a happy parameter. And I think now we try 3 or 5 times, and then we simply throw an error.
Okay, thank you.
Yeah.
One of your slides showed the clustering.
Pipeline.
Yes, and one of the results was, you try different clustering algorithm, and even though you try to make it more specific, it still returned very generic clustering. Why do you think that is? Because you would naturally think that you, given it better classification, you would produce better clustering.
Yeah, sure. So the thing is that this is not clustering algorithm yet, and this is a step before clustering, where we try to shrink vectors. And in case of, it works for almost any data. But in case of embeddings, they are already so densely packed with information that we cannot reduce it any further. And if you like remove half of dimensions out of it, it will try to, well, keep the meaning, but it will be too blurred. And so they become too generic again, and then clustering algorithm itself doesn't really know what embedding referred to at the first place. And so that's why it doesn't work. And that was kind of fascinating. I was sitting for 2 weeks trying to make it work because it was written like everywhere that it should work, and it wasn't. So I was pretty excited when I found it.
You saved somebody a lot of time.
Hopefully that's what this conference is for.
If you're attentive enough, OpenAI in their documentation, they write explicitly that you don't try to make dimensionality reduction.
Yeah.
I have a question about data safety. Seems like you run your AI model on the entire user space, and there can be sensitive company data, and then you just send it to OpenAI, and then you send it to Pinecone and store there. Are there any security consideration that you did, or maybe user can disable that if he thinks that he doesn't trust these companies?
Yeah, for sure. Vector search is not enabled by default in Fibery. You have to enable it and actually by hand add data you want to use. So that's like the first security measure, if you can call it. But then we also, for example, for Pinecone, we store all the data in EU. So we are compliant with GDPR. For OpenAI, right now we use it, but as I mentioned, by the way, we tried now to host embedding model in-house, not using OpenAI, exactly because of the concern you mentioned, the data leakage and so on. So yeah, we are working on it actively.
Thank you for the talk. I have one question also about data privacy. How do you separate your clients? I mean, do you have separate models for the clients? And if you don't, how you manage this? I mean,
sorry, I couldn't hear question clearly. Yeah, sorry.
Yeah, I suppose that you have separate clients, right?
Yeah.
And their data should be separated.
Yeah.
And I would like to know how you manage this. Do you have separate models, separate prompting, or separate databases, or you have some different ways?
Yeah, and the question refers to clustering, as I understand, right? So, or to overall, like how we manage it. Sorry, but it's
mainly about database, but
also
on the clustering level, if you have something.
Yeah, on database level, we utilize Pinecone, and it allows us to split database on namespaces. So we just assign namespace per account in Fibery, and this way we split the data up.
And what about scalability then?
That exactly what serverless is for, because serverless allows you to scale very quickly. They charge you exactly in a pay-as-you-go. So if we use, I don't know, 10 gigabytes to store data, they will charge us for 10. But they are ready anytime to provide us 100 or 1,000. Hopefully they will.
Okay, thanks.
Guys, we got a time just for the last question. We're gonna have a break afterwards. Please approach speakers, but for now, the last question.
My question is about that curious fact about vector substitution. You mentioned that if we subtract Paris from France and then add Madrid, we'll get Spain. Does this work with numbers, with words representing numbers?
Oh, that's a really good question. I have no idea. No, really, but I have to test this one out. Thank you. I suppose it... No, I think it shouldn't be like this. Because numbers, well, how you would represent in embeddings the difference between 7 and a 5, right? I presume they would be just all over the place.
I think it shouldn't be like this because then numbers become closer to other words than to other numbers.
Oh, yeah.
Right?
Yeah.
Thank you.
Thank you.
Guys, we need to wrap up. Thank you so much for the talk.
Thank you.
Whose questions you love most, because you have at least 3 invitations to the after party?
Oh, we have to decide it now.
Well, you can, guys who ask the question, you can approach and fight, but you can...
I know, because we have to give a book to the best question in the audience.
Yep. Okay.
It may seem biased, but the last question was awesome. So I would like to give this question. So if you can come to the stage and later.
Yeah, and please don't hesitate to approach speakers to get, maybe they choose you for the after party. And for now, we are having 15 minutes break before the next talk, and see you here in 15 minutes.
Thank you.
Yeah.
Работает.
Yeah, so seems like we're gathered, and I'm happy to introduce you our next speaker, Andrei Chipsov. He's ex-JetBrains employee, and now he's building his open source tool for managing AI infrastructure. It's called dstack, and he's going to tell you how to make it effectively, right? Welcome.
Hi everyone. Super excited to
the mic.
Awesome. Yeah, hi everyone. Super excited to be here, and also quite excited that AI is kind of a spotlight here. So the first talk was also about AI, and I'm really glad that it's getting more attention at every conference, regardless of what this conference is about. And today, this talk is also not an exception. My name is Andrei. Like Kate said, I'm working with dstack. And before that, I worked at JetBrains for quite a while. And working at JetBrains is a dream job because you, as a developer, you can build tools for other developers. And some people actually really like it, which is in my case, because, as a developer, you not only work to get paid, but also to enjoy what you do. Because in the end, you spend a lot of time with your laptop, and if you don't really like what you do, it would be a disaster. And it just happened that JetBrains, we try to make their developer work more enjoying, to let developers enjoy what they do. And at JetBrains, I've been working with multiple tools, of course, but for example, the last couple of years, I've been working with PyCharm. Raise your hands if you know or use JetBrains tools. Oh, wow. Didn't expect, honestly. So yeah, I worked with PyCharm, and this gave me a chance to also interview a lot of ML engineers and ML teams that it was almost 3 years ago. You can imagine it was all before the ChatGPT moment. And back then, we actually called it ML, not AI. And this was a unique chance for me to talk a lot and see how, and I was surprised to see how often they actually have to struggle, because as an AI engineer, when you actually work with your model, with your data, and it's not something that you can always do using your laptop, for example, compared to, let's say, front-end development or back-end development, which you actually can do on your laptop. With everything that involves data or AI, there's also infra involved. You need infra, and regardless of how expensive your MacBook is, most often you would need even more expensive infrastructure. And back then, I realized that indeed managing infra is not an easy topic. Also, I'll be throwing questions, so I'm curious if anyone heard of what Kubernetes is? Good, awesome. And who's using it? Oh, wow. Yeah, sometimes I'm a little bit afraid attacking Kubernetes because we actually built a replacement for Kubernetes. And I remember that there was a funny moment when somebody else okay, so you're building a replacement for Kubernetes, but what do you use Kubernetes inside? I'm like, no. Why? All right. And yes, I quit JetBrains more than a couple of years ago to fully focus on dstack, which I'll be talking about today. And we are a small but growing team, and everything we do in open source. And maybe that's a good chance if you can scan and find dstack on GitHub. And then at the end of the presentation, if you really like that, you would probably even give it a star. If not, then just, I don't know. There's no way to get a star. Awesome. And I'll have let's say, formal part of their presentation with some slides. And then we'll switch to a bit more hands-on part where I'll just show the documentation and we'll walk you through what dstack is, how it is different from Kubernetes and all. And because we are building a replacement for Kubernetes for AI, I'd like to start with outlining some of the trends that we see happening in the market. And of course, it's not a surprise to anyone that, well, something is happening, right? So everybody is talking about AI, so there must be a reason, and it should also have some reflection in the real world. And what we can certainly say is that there's a skyrocketing demand for AI infra. Well, obviously, because everything what happened after this ChatGPT moment, we see a lot of new cloud providers appearing, and Max mentioned Runpod in the previous demo as one of their providers that now challenge hyperscalers, and they actually call themselves now clouds, not just clouds, but now clouds, maybe because it's just cool. On the other hand, it's when you call yourself, when you focusing on GPU mostly, not just on normal things, but mostly around AI. And then it's called now cloud. Of course, so there's a lot of data centers, and we'll see why that's a thing also for data centers. And finally, of course, the accelerators. So it's the time for the accelerators. I mean, probably the best way to prove that would be to look at their stock exchange for the NVIDIA stock. So basically, this is almost 2 years ago. This is when OpenAI released ChatGPT, and you can basically see that it's now 9 times more expensive, the stock, and there should be like a reason why this happened. But what it also means is that there's a huge demand for the infra. Somebody is buying these GPUs, somebody is installing these GPUs, probably those might be data centers, some of these GPUs are offered through the cloud, probably someone is using those GPUs. So that's the implication. And of course, now it's not just NVIDIA, we also see other players here in the game. Well, I personally didn't expect to see how well equipped AMD here, and just in time, out of nowhere, they now present this MI GPUs. Have anyone heard of AMD and their latest GPU developments? All right, not very many, but I must tell you, they actually have also GPUs, and they also enters the chat basically, and so we're going to see a lot of development from AMD as well. And of course, not to mention other accelerator manufacturers like Cerebras Systems and many, many, many more. And finally, one more interesting trend here is, of course, the open source. And probably who've ever tried any open source models? All right, there's the room for improvement. Basically, oh, that's AI in action. Well, maybe ask someone to fix this. Cable. Should I do? All right, never mind. Awesome. Who was that? Who was that? Who suggested to plug it out? Anything again? Okay, so this waits for you. All right, awesome, thank you. So now open source models also enter the game. And of course, Meta is one of these companies that is pushing this forward with the Llama model. But it's not only limited to Meta. We also see other companies now entering the chat. In exactly a year ago, in November, I don't know if you followed, 𝐀𝐠𝐞𝐧𝐝𝐚 is a founder of Hugging Face. Basically, the service that allows us to host open source models, to share them with the community. He made this prediction. I mean, a lot of people making predictions. It's a pretty popular game. You don't even have to be right. You just make a prediction, and then some people just forget what you said. However, a year ago, 𝐀𝐿 also made a number of predictions, and one of the things that it said is open source LLMs will reach the level of closed source models. Raise your hands if you share this belief. Come on. Good one. It's waits for you. So this is the chart, actually carefully plotted by Maxime Lebon, is an engineer in Liquid AI, if you know. He just puts the timeline for all the models, and on the left-hand side you can see the score. The MMLU, it's basically a benchmark that measures how a model behaves on different set of tasks, and also like how well it's at reasoning. And the higher the score, of course, you can imagine that the model is more expensive, or let's say better, right? And we see that on the again left-hand side we see these closed source models, right? Like the first version of Claude, then GPT-4 is over there. It's like really good, and it was released basically the beginning of 2023. And now we see that on the right-hand side, this, I mean, you don't see the color here, but if you see the number followed by B, it most likely means that it's an open source models, means that B means billions. Billions means parameters here. And you see that as numbers grow, we get better performance. And basically in October, Meta released Llama 3 model, which actually came really close to what OpenAI has. And then the process got even faster. And this is like 1 month old slide. So a lot of things you can imagine happened during this month. We got 𝐀𝐿 model by Alibaba Cloud, which actually surpassed the quality of Claude. And then it was, they did that by building a model that has much fewer parameters. This is out of the scope for the presentation, but the number of parameters really matters, because the more parameters the model has, the more expensive it is to run that model. The more GPU memory you need, and more expensive the process goes. And the greatest thing about this open source development is that it's not just enough to build a model that beats the closed source provider, but you need also to come up with fewer parameters, so this model is easy to be used with your data center, with cloud, and so on and so forth. And yeah, basically, just recently, for example, for code generation, 𝐀𝐿, again, these guys from Alibaba Cloud, they released a very small model, which actually like beat it, the Claude code generation model. So it's just another way to say that open models are here, they are here to stay, and they rival the closed source models you can imagine. And of course, it's not just open source models, it's also the open source frameworks and tools. You can imagine companies like OpenAI and Anthropic and Together AI and Fireworks and many more. They are called normally managed services. Something like they typically promise you, okay, so just click this button and this model works on your data, and pretty much you don't need to do anything except basically paying for that. And this is called managed services. And now we see that they get very this gets very crowded. A lot of managed services appear, and it becomes pretty reddish ocean. But in the end, most of these managed services actually use open source tooling behind. They use pretty much same, like optimized kernels for the GPU. They used same frameworks for fine tuning. They use same frameworks for inference. And this is great, because this is by basically giving back to the community. At the same time, they make the core stack more mature, but that also at the same time, it basically the mode shrinks, and it's get more difficult for them to be to compete with each other. But this is exactly what is good for the community. So basically everybody like here benefits out of this process, because running models and training models gets easier and easier. So finally, concluding this list of trends, very important one. So a lot of companies now played with OpenAI, and they now, okay, thinking, we did this proof of concept, so how do we do now that with our data? And like we actually heard with the question at the previous demo, people start to think, okay, so but what about the data privacy? I mean, how come that you can share my data, customer data, with an external storage? So that creates a lot of problems, and that highlights the fact that privacy becomes like a super important topic when it comes to AI, and probably some critical factor here. This is a chart from one of the surveys Anderson Horowitz did in March. They basically sat together with some leaders, with some Forbes or whatever they call it, like big companies. And they asked it questions, basically, what is your plan? So this happened in the beginning of the year. You can imagine with all that development in open source models, how this could change. But basically they asked, okay, so what are your plans? Do you already use open source, or do you plan to use open source, or maybe you don't? So you can see that 41% actually said that they already use it. And other 41% said that they just wait for these open source models to get more mature. And then there was another question in the same survey about, okay, what is the main reason? Why do you really consider the use of open source models? And as you can imagine, I mean, the question was designed the way that first you give like, just choose multiple reasons, and then you say which one is the main one. And as we see, control and customizability are two most popular choices here. First one, control. It's by using open source models, you can have more control over your model. So you don't depend on an external service provider that can change the behavior of the model, or which is very important. And then also privacy. And then customizability is how easy it is to customize that model. And we know that also in the previous topic, it was highlighted that one of the advantages of the open source models is that you can easily customize, fine tune, build on top of them. So, and then of course, when companies were asked to choose what is the main one, it's control basically. Because imagine yourself as a big business, and then at a certain point, your business starts to depend on the behavior of the model. You basically put the whole business at risk if you make it depend on an external model provider. That's what actually pushes the companies to consider open source. So now you can imagine that a lot of enterprises, they consider the use of open source models, and then they think, how can we use these models in production in our case? It means that the companies need a way to orchestrate these workloads, because now if, for example, you switch from OpenAI or a similar company to hosting these models yourself, then you have a dilemma of how to basically do that at the efficiency that OpenAI does it, for example, in both training and inference. And if you come to think that all those enterprises, they have very different cloud providers, they have different even hardware, the data centers spread in different regions, and they certainly need a common way, kind of a standard developer tool to orchestrate those workloads. And it just happens that Kubernetes by today is the only standard that allows us to manage infrastructure regardless of the vendor, be it cloud or open source. And thanks God that we have Kubernetes. However, when we look at the AI, we see a lot of issues, let's say, or bottlenecks that Kubernetes is associated with. First of all, Kubernetes was not designed for, let's say, AI tasks. It was mostly designed for DevOps tasks, where the main use case is they're deploying the production code over cloud and on-prem. That's why the abstractions that Kubernetes offers they are a bit more low level, and you at a certain point have to choose. Either you are an AI engineer or you are a DevOps engineer. And it's really hard to actually do this both. And also worth mentioning that with Kubernetes, Kubernetes is a low-level abstraction layer, which doesn't come with AI essential tools. As an AI engineer, for example, you need high-level abstractions for managing clusters. Now I need this cluster, tomorrow I need that cluster, and better not doing it with, well, creating a Jira ticket, then going to your data platform team, and then talking, exchanging emails with them, finally to tell you to hear that, well, it's a bit difficult to arrange that cluster for you. So this is, I mean, exaggerated a bit, but that's what AI teams often have to go through, because, well, all of that is managed by the MLOps team. MLOps team is in charge for managing your Kubernetes cluster. And it just happens that there are very few, and you are an AI developer, part of a bigger team. You see, basically, we actually call it MLOps tax. A company, in order to use Kubernetes for ML purposes, has to pay MLOps tax. Means you have to hire DevOps, you have to hire Kubernetes people, you have to invest heavily into that, and then ML community doesn't stand still. The stack actually evolves pretty quickly, so your MLOps team is under heavy pressure. And this what hinders most companies to actually, do a lot of development, use more expensive hardware, and do basically ship AI into production. And finally, to mention that while Kubernetes is a vendor agnostic standard, you can think that you can use Kubernetes with AWS, with GCP, with Azure. However, when it comes to AI, what we often hear from teams is that, sometimes you actually want to use several clouds because of the availability of the GPU and everything. And then also, sometimes you actually want to use on-prem. And Kubernetes might allow you to use particular cloud or on-prem, even though with on-prem it's not that also straightforward. But there is it's not possible to use multiple clouds or hybrid, for example, cloud and on-prem. So that's one of the issues with Kubernetes. Right, and with the rest time of this demo, I'd like to talk more about what dstack is, and for that I'll probably switch to the documentation, because that's the best way to explain what dstack is and walk you through the use cases. All right. So once again, when at the beginning of the presentation, I said that we're building an alternative to Kubernetes and Slurm. But let's now focus not on Slurm, but on Kubernetes more. And just like Kubernetes, dstack is a container orchestrator. So how many of you ever used containers? Oh, wow. I mean, what are you doing? Basically, I don't have to explain what container is. Maybe just mention that, well, we all use containers because it's the easiest way to pack your dependencies and be sure that it's going to work anywhere, doesn't matter where you run it. And then somebody or something orchestrate these containers. And I would just say how many workloads I need, or at what scale I should run it, or at which infrastructure provider I should run it, and then this something will basically implement that, or orchestrate that, and this something is called container orchestrator. When we are using Kubernetes, this container orchestrator is called Kubernetes. And if you come to think, then each cloud provider implements this managed Kubernetes. For example, when you start using Kubernetes with AWS, it means that there's somewhere on the AWS side, there's this container installed. You might also know about this control plane that is in charge of what is running. But normally, as a user of a managed Kubernetes, you don't know that. You basically just use the service by a cloud provider. Or if, for example, you are very brave and install the Kubernetes on-prem with your own cluster, then basically you install that software and you have to manage it, or buy some expensive, or maybe close to expensive enterprise offering for on-prem. But basically, what I try to say here is that just like Kubernetes, dstack is also a container orchestrator. But let me walk you through some of the differences. So difference number one is that the number one thing that dstack we consider very important is to be vendor agnostic. That's why when we design dstack, we chose deliberately that we don't want to rely on the vendor for the managed service. We want you to be in full control. Basically, it means that you install dstack wherever you want. Could be your laptop, or it could be dstack, like it could be some server, and then you point it to the cloud provider or to your on-prem infra, and then you don't depend on them. But dstack basically is able to provide you control plane for that. But I'll explain more what that means. Another one is because we built a container orchestrator for AI, we basically built in the accelerator support as a first-class citizen. Means that when you run something, you actually specify exactly like what kind of accelerator you want and what kind of VRAM you want. With dstack, you would probably need to use custom operators and then label nodes and invent certain kind of things. Right. The best way to explain dstack is to walk you through the process of from how you install it, how you configure cloud, to how you actually use it. So in order to use dstack, of course, you have to install it somewhere. And the easiest way to do that would be by using pip. You just pip install dstack, and then you invoke this command, dstack server. This command basically starts the server where you run it. And it, as I said, it could be your laptop, or it could be somewhere in a like a cloud environment or in your data center. And then that is it. So there's a control plane running available at this address. Now, anyone who is given access can basically use the CLI or API or dashboard to interact with that server. So let's now talk a bit about the cloud support. In case you'd like to use dstack to orchestrate your cloud workloads, you would need to configure so-called backends. There are multiple ways to do it, but the most simple one and straightforward one would be just create a YAML file where you basically give their credentials and other settings to dstack. And this way, dstack understands, okay, so now for this project, the user configured, the admin configured AWS account, configured whether I have to use some VPCs or not, basically just provided these settings. And on the right-hand side, we see a list of cloud providers here. These are the cloud providers that dstack supports out of the box. And because dstack is an open source project, it is possible to extend dstack with more cloud providers. And as you see here, for example, runpod is just one of these providers. Basically, if you just open this file and configure your runpod credentials, then dstack would be able to now orchestrate and scale up and scale down these workloads in runpod as well. And this would be very close to using, for example, serverless feature of runpod, with the difference that here you have this infrastructure as code paradigm that everything goes through dstack apply, but then you also have a flexibility of switching between cloud providers and have same functionality with any other cloud providers, and then also combine this also with on-prem. Which we'll talk about, hopefully, if we have enough time. But this is only to say that dstack allows you to configure multiple cloud providers. And this is very easy to do. You don't need to do anything. You just need credentials from the cloud provider, and you can configure as many as you want. So now imagine that you've created that file, you stored the server, and then you brought the users, let's say AI team. So now they can use the CLI or API to basically run their workloads. If, for example, we compare dstack to Kubernetes, where with Kubernetes you have these low-level abstractions like pod, like replica set, like load balancer, like for traditional development. When it comes to AI development, you typically thinking of something more simple. And let me walk you through this concept that dstack offers, and we'll start from the most simple one, like trivial ones. Let's first start with the dev environment. Sometimes, not very often, but sometimes you actually need some interactive environment. You just say, okay, so let me just use my IDE with this GPU or with that GPU. Let me use my notebook or whatsoever. It's just that I'm going to use in my laptop, but I need some hardware that I don't have locally, but I still would like to use interactive way. With dstack, everything goes through the configurations, and you just create a configuration called dev environment. You specify the requirements. You can choose your Docker image, your dependencies, and then, of course, the resources. And there's a very rich syntax of how you can ask how many GPUs, what kind of GPUs, what providers. And then what you do dstack apply, and then dstack looks at what cloud providers are configured or on-prem clusters, which are also mentioned hopefully in a while, in a moment. And then dstack either reuses some of the existing capacities that are there, which we call fleets, or it provisions them on demand. And then it offers you this URL which you can click, so you can access the dev environment through your desktop IDE. And work with it as it runs locally. In fact, that it runs in any configured cloud or on-prem cluster. That was easy. Now, what about more, let's say, complex task? Now, let's imagine that you want to run a web app or a batch job. Let's talk about the batch job. With the batch job, it could be either one node batch job or it could be distributed batch job. Like, for example, fine-tuning. You have your script, you have your Docker image, or you don't have a Docker image, but you know what libraries you want to use. And with that, you just specify the type of the configuration task, specify the requirements, and then you specify the commands what you run. And this can be any commands that run either locally or through SSH. There's no need to change any code. You just specify the commands, and then, of course, you also can specify the resources. Maybe mention very quickly that dstack out of the box supports the distributed tasks. Imagine now it's not enough to have one node with 8 GPUs. You'd like to use 2 nodes with 8 GPUs each. And then all you need to do is to specify these tasks. And then dstack allows you to use this, what we call system environment variables, where dstack automatically propagates. It basically, dstack thinks, okay, you need a cluster of 2 nodes, and I'll provision that. I'll ensure that it's highly interconnected cluster. At the same time, what I'm going to do, most likely you're going to do something distributed, means that there's going to be a head node and then workers. And then it basically provisions those nodes. And then it knows this is a head node IP address. Those are worker nodes IP address. It knows how many GPUs per node. And then whichever distributed framework you use, Ray, Spark, Torch Run, anything, they all support this notation. And all you need to do is just pass this as command line arguments. And then dstack would basically, once it provisions that cluster, then it would just run the head node script, and then it will run this worker script, and that's it. The dstack framework, the dstack orchestrator itself doesn't have to know anything about it. It just orchestrates the actual distributed framework which you use. For example, in this particular case, we are using Torch Run for fine-tuning. But let me go back. Once you define that task, you again using dstack apply. And then this works pretty much same way. If there's already provisioned cluster, then it just uses it. If there's no one, it will provision that automatically, and then it will run the script. You are also allowed to use any ports. You can also use tasks for running web apps. Imagine that you'd like just to run, I don't know, Streamlit app, let's say. You need resources. You would, let me show you how a web app would work. So here's a Streamlit app. You just say, okay, type task, this is my requirements, and basically just use Streamlit hello. And then you specify, okay, I need those ports to be forwarded. And then when you do dstack apply, dstack CLI would automatically forward those remote ports of your Streamlit app to your local machine, because it runs it in the attached mode. And you can access this Streamlit app as you run it locally. Basically, you can actually click localhost : 8501, and then it will access the remotely running Streamlit tab, which is pretty powerful and simple, and it allows you not only to run web apps, but also any kind of jobs, regardless of how complex those are. For example, with AWS, if a cloud provider supports this infinity band or some other fabric, let's say that allows you high interconnection between GPUs of the nodes, the stack would provide that automatically. You just, if you are using an instance that supports that, it would work out of the box. And then in that case, fine-tuning would be extremely fast. Right. Now, let's speak very quickly about services. All right, so we've fine-tuned something, we've experimented with the model. Then imagine that you'd like to just run inference for a model. This is how you do it with dstack. You define again the configuration file where the type is set to service, and then you can again specify any requirements, and then you're free to use any serving frameworks. Like for example, we know PLLM, TGI, there are many more that you can use, and you have full control over that. It's just that now you specify not many ports, but one, because it's a service as an endpoint. dstack will auto-scale it. And then you can also register if you want this is as a model, and then dstack would basically provide you this model through a common gateway. If your team deployed multiple models, you basically utilize those models through an OpenAI compatible interface, basically as you're using OpenAI within your team with multiple models deployed. Right, again, you specify the resources. Now, when you run it, obviously, dstack allows you to access that endpoint through the dstack server proxy. Dstack server by default proxies the traffic. However, if you'd like, for example, to configure a more sophisticated ingress, then you would create this gateway configuration, and you can configure it in many different places you want with clouds. And then dstack would let you handle basically their custom domain, HTTPS traffic, and everything else as you want. But you don't have to do it for development purposes. If you are only developing and not serving any models in production, services is just enough, and it works out of the box. All right, maybe we're getting there. One more important thing to mention here is that whenever you are running something with dstack, dstack tries to reuse an existing fleet. I mentioned that dstack needs to provision some capacity, and this capacity is called fleet with dstack, and dstack uses this backends, cloud backends, to provision that. For example, if you configured runpod or Lambda, dstack would provision these fleets in this particular cloud provider. And then if you, for example, stop something, dstack by default keeps this capacity idle in a pool. And then if you run something again, and if this fleet is idle, it will reuse that. And you can configure for how long time it stays idle. For example, by default, it stays idle 5 minutes. If you don't use your instance again, dstack will automatically turn it down, so you don't pay for that. However, you can, of course, configure for how long it stays. However, in certain moments, you would like to have a tighter control over that, like how much it stays idle, or which particular setup for this cluster to use, whether to use interconnected or not. So you'd like to have a tighter control. In this case, you could create this fleet configuration, and you could also tell, okay, what exactly you need, and then you invoke dstack apply, and dstack would provision that fleet and make it ready for you. So whenever now you run anything, dstack would reuse this fleet out of the pool, which gives you this tighter control over the life cycle of their, let's say, fleet. For example, if you are managing a lot of workloads and you have certain rules when you'd like to provision and deprovision your infrastructure, you would be able to use these fleets to basically optimize the costs for the cloud use. So now, finally, imagine now the situation when you'd like to either combine the cloud use with on-prem use, or just go with on-prem and run your models or like training workloads using your on-prem like GPUs or machines. And typically with the Kubernetes, that would require you to manage that on-prem cluster and actually use it. With dstack, we try to make it even simpler. So imagine that you'd like just to use these 2 hosts. that are within your network. They are already set up with GPUs. And you actually have a private SSH key that gives access to those nodes. With dstack, you would create this fleet configuration, and you would add this section SSH config, where you would list the hosts of these on-prem machines and provide the SSH key, and then you would do dstack apply, and dstack would automatically use the SSH key, would connect there, and you'll see this particular cluster as your fleet. So now whenever you run something, you are able to run your workloads using this on-prem fleet. So as you see, you need 0 MLOps engineers, you need 0 DevOps engineers. And your AI team can do development, can do fine-tuning, can do deployment of models at scale without any, let's say, internal development. So this is, and at the same time, you are able to reuse multiple cloud providers. You can use them in parallel to help with the availability and costs. And then you can also combine that with on-prem, which must be much easier than Kubernetes. So it is not possible to cover everything, but dstack has other concepts as well, like for storages, and for like permissions, like things like, for example, in Kubernetes, like namespaces where you can isolate different projects from each other. But that's not a lot. A quick check, how much time do we have? Do we have like 5 minutes, or we do? All right, just to give you a demo. So let's try to use it. So here we go. This is the, let me restart it to show how it works from the scratch. All right, you typically, imagine a very simple case. We have some cloud account. It could be Runpod, or it could be some other provider. In my case, I'm using now Lambda Cloud, but it's pretty much similar to Runpod. What I'm going to do is I'm going to install, of course, dstack. Let me necessarily not update. Let's just install it. So now I can just start dstack server. As I mentioned, dstack server by default reads this configuration from this file. And if we open this file, we're going to see that, look, there's one project only. It's called main. We configure backend type Lambda, and we provide a Lambda API key. Hurry up to make a photo, and then you can use GPUs for free. Right. So now the server is up, and it means that we can use that server through the CLI or API or through the user interface. The CLI basically looks like this. So this looks a bit somewhat in the direction of Kubernetes, but it's a bit simpler. And then if we open the URL, we see that it comes with a control plane. Basically, you see all the projects you've configured. We have only one here. We can see, existing volumes, fleets. We see all the runs. We can configure projects, and every user has a token. It's not possible to use dstack without a token, but that allows to manage permissions and really know who is doing what within your AI team. So now dstack server is running. Well, just 10 minutes before this presentation, I actually created a fleet out of this configuration. I just here I have one node, and I just say, okay, so give me A10, and then I use this apply command where I pass this fleet configuration. So because I actually ran it 10 minutes before the presentation, it shows me that, okay, so fleet is already created, no changes detected. Now if I use the dstack fleet command, it's going to show me that, okay, so I have this instance already idle state. and it's there until I decide to kill it. I didn't configure any idle time. If I've configured idle time, then the stack would basically count moments to turn it down. And so now means that I can use somehow this little fleet of mine. So let's start with a very simple one. All right, what do I have here? Okay, so here we go. This is the dev environment. I just say, okay, so give me any GPU from 24 to 80 gigabytes. I'm going to use Python 3.11, and I'm not using any custom Docker image. If no custom Docker image is specified, the stack uses its own with the configured drivers. So now I do this. Reuse is just a flag to ensure that no fleet is created and I'm reusing one of the existing ones. This is when the stack basically decides whether I have to provision anything or whether I can use one of the existing ones. The provisioning works this way that if we provision, the stack would use their cloud APIs to provision that VM or bare metal for that matter, and then it would install dstack.𝐀𝐠𝐚. Dstack.𝐀𝐠𝐚 is an internal component that takes care of the status of these containers and everything, and then it would run the container, and the CLI on the user side will basically handle the port forwarding and everything else. So now as we see this URL basically telling that, hey, this dev environment is up and running. So now we just click the URL and the desktop VS Code ID basically automatically connects to that remote instance. Great. We also can see that this stack automatically took your repo from your folder where you invoke dstack apply, and it automatically synced this repo with the remote machine. So now we're on the remote machine, but we have all the files that we had in the folder, including all the local changes. If you change something and do dstack apply, and this will reflect in any remote environment which you run. And of course, if we run the NVIDIA SME, we're going to see that basically we actually have this A10 instance. But again, this is just to demonstrate how dev environments work. We just stop it. And then when I stop it, dstack cleans up, dstack tracks all the hardware metrics, all the logs, and then when your instance is even killed, you'll be able to watch what happened there. Right, dstack, like if anyone used Docker stats, the command that allows you to see what's going on in terms of metrics inside the container, dstack actually has also such a command. It just takes the run name, and then it also provides you how much GPU is used and other metrics, which is pretty helpful when you do development. So now maybe final one, 2 minutes to count, right? So let's go and run something cool. So here's a Llama configuration where I'm just using VLLM. Let's just go ahead and run it and see what happens. Oh, Llama. Cool. We're going to reuse the same instance, and for Llama, 24 gigabytes would be just enough. Right. Maybe while we see that is getting launched, a quick one. We're going to see the fleet here, and it's shown as busy. If we run something now, this stack would show that we either provision a new one or just don't do anything because this one is busy. Now we also have here models. If we specify certain service as a model, it means that we register that as a model, and means that we'll be able to use that model through the user interface, or of course the OpenAI compatible API. If we click run here, we're going to see the logs here as well, and all their state, and you can also manage things there. If you have a project, then you would see all the runs from your team, but you won't be able to see or manage anything in the project that you don't have access to. Right. Have to wait. Pip install is the slowest thing here. Even Moto is downloaded faster than pip install. Right. Maybe while we wait, dstack also allows you to manage cache. This is what lets you optimize the inference time, like cold starts and everything. We can actually see how it works here. Llama. If we see here, we specify not only the requirements and commands, we also specify volumes here. Here, we can use either network volumes, basically to persist something in the cloud, but we can also persist something inside the host. In this particular case, we mount the Hugging Face cache folder to the instance folder. And now, if we rerun the same model on the same instance again, dstack would need to download the model. You would just reuse it from cache. So now we see basically that it's running. And if we switch to the user interface, we're going to see that this model is running, and we can do basically this to check that it works. So this is Llama running in Lambda Cloud, and you have full control over that through the CLI and user interface. And with that, happy to see if you have any questions. Thank you.
Are there any? Pizzas are getting cold, so two questions.
And sorry, everyone, that I stand it between you and food.
Hey, so what's the catch? What's the paid features of it?
Paid features. You wouldn't believe if I said there's none, right?
I don't know.
Thank you.
I'm waiting for it.
It just happens that we do have only one paid feature, even though it's not possible to find on our website. But we now have some big companies that are using dstack, which we are helping, of course, use it. And so far, the only paid feature they ask us for is an integration with single sign-on. dstack itself has this authentication, and you can manage tokens manually. But for some companies, they just want to integrate. I mean, you can even integrate it yourself using the open source one. But with enterprise, it's just there.
I get it. Thank you. Don't forget to revoke your API key.
Thank you.
Any other? Go ahead.
Oh, okay, thank you. Yeah, thanks for that presentation. I'm just curious about, you mentioned that it's possible to handle like different cloud providers in one time. And also I noticed that there was some like cost labels that show the price. Is it possible somehow to set up that it will, for example, say, hey, buddy, for example, this cloud provider is out of money. We can, maybe let's use this one.
Yes, that's out of the box.
Oh, nice.
If you configure, for example, runpod and Lambda, dstack would automatically offer you, we call them offers that are cheaper. It will pick any that satisfies the requirements. You don't necessarily have even to specify the version of, the name of the GPU. You can say, okay, so CUDA compatibility version this, and then VRAM from this to that. dstack would automatically collect offers from multiple providers and will offer you what is available, and it goes one by one. If something is not available, it will, you can even configure that retry policy. For example, you can say, okay, I need that particular instance now or tomorrow, just go for it, get it to me. And then dstack eventually will get it and will run what you want. Right, and you also see the price. And actually another one which some companies ask us for is being able to manage these team quotas, because they don't once again wake up and then just see out, even though that can be managed with the cloud providers as well. But yeah, totally.
Thank you.
Right.
The last question.
Where's pizza?
Thank you for the speech. I have a question maybe about installation process. It looks so painful. Did it available under Nix package
I'm
manager?
sorry, say it again.
Did dstack available under Nix package manager?
Good one. No, but we accept pull requests. Seriously, I mean it.
Yeah, thanks a lot. Don't hesitate to approach Andrei to ask your questions. He's still got his 3 invitations to the after party. Andrei, thank you so much.
Thank you.
And guys, as far as
Let's start. Okay, cool.
Hey, so how was the pizza? Hey, alive? So, good. So, in my view, one of the very interesting part of the meetup starts because now we're gonna see how actually AI helps building new products and how even non-technical guys can do that and maybe to revolutionize the pharmaceutical industry. Let's see. I super happy that our friends from London arrived from 𝐀𝐿�𝐚, and they're gonna tell you actually how they built their application and using the product that already had been mentioned today. Let's see and let's welcome them.
Well, thank you. I hope everyone has enjoyed their pizza. I certainly did. This will be a little bit different from the rest of the talks today, a bit non-technical, but hopefully you'll enjoy it nonetheless. So my name's Will. I'm with Hank today, and we're the co-founders of 𝐀𝐿𝐴. And this is an AI company looking to transform the pharmaceutical industry. So what I'm going to go through today is a little bit about 𝐀𝐿𝐴, who we are, what we're about. We're going to look at the AI opportunity in the pharmaceutical industry, specifically for pharmaceutical review. And then we're going to discuss some of the challenges that we had as non-technical founders building this thing. And then also talking about how do we find a really cool no-code tool, which has been discussed already today, to build the whole framework for how we operate this system. It's really, really cool. So this is Team 𝐀𝐿𝐴. We are a small but mighty team. And as I mentioned, Hank and I, we are not technical founders. We've actually spent most of our years of experience in the pharmaceutical industry. Some big pharma, some small pharma, some things in between, and also some time in the healthcare sector. So we knew that area really, really well. But we're also big tech enthusiasts. Hank and I have been following AI since the public release ChatGPT. We're big tech geeks. So we're non-technical founders, but we're definitely enthusiasts. And we combine obviously our forces with OTS. So we have Vlad and Anton joining us. Amazing experience in front and back end engineering. Anton's actually the CTO of OTS. So really happy to have him supporting 𝐀𝐿𝐴 to really bring this product to life. But we are growing. It's a really exciting time. So if you're interested and you like what you hear, get in touch if you think you can add value, or get in touch with the OTS team. We'd love to hear from you. So let's discuss the problem in brief. I know we're in a technical audience here, so I'll try and break it down to kind of the core issues of what we see in the pharmaceutical review space. So pharmaceuticals, as you know, create medicines, right? That's the biggest thing they do. The second biggest thing they do is tell people about their medicines, whether it be the public or the patients, either about how these medicines work or what the diseases are. And they spend a lot of money creating content. In fact, I seen a statistic the other day showing that pharmaceutical companies actually spend more on content generation than Disney. So it's absolutely crazy. It's a huge part of what they do. But this industry is super regulated. You can't just say whatever you want about a medicine. You have to be really careful. You can't just say, my medicine cures X, Y, and Z, when actually it's not very good. You've got to play within the rules, and there's very, very strict laws about what you can and can't say about these medicines. The second thing is that I mentioned there's a huge volume of these materials being produced, and they all have to be signed off and regulated by these laws. In the UK, which is where we operate at the moment, there's around about 2,000 to 8,000 documents per year. And the big kicker is that it takes these documents, on average, one document about 2 weeks to approve. Now, that's not generating the content in 2 weeks. That is having the content ready and trying to get it out the door to your customers. So that is a long, long process. It's very, very inefficient. And you can imagine, scale that globally, it's a huge problem for the industry. It's loads of time, it's loads of money. So to help you understand this process a little bit in detail, I've kind of drawn a little schematic here. So bear with me. So most material for promotion starts its life at a creative agency. So they create a great advert, a great podcast, a great video about the medicine, and usually the marketing manager holds the budget. So they tell the creative agency, hey, make me this material. They get the material, and the marketing manager's like, yes, this is brilliant. Right, we're going to use this now. So he sends it to the medical reviewer. And the medical reviewer's job is to look at this document and say, does this apply with the law or not? Usually they look at it and say, there's a few things I don't like here. I don't like this, I don't like that. They send it back to the marketing manager. And there's a little bit of friction there. It's almost like the unstoppable force against the immovable mountain. The marketeer wants to push the boundaries of what can be said. And the medical reviewer is there to sort of keep them in check and say, hey, some of this is going to break the law. We can't say that. So it goes back and forth, until eventually they agree. But that's not all. It then moves to this final person called the medical signatory. I used to be one of these people. This is the person who signs off the material with their signature and says, this completely complies with the code of practice and all the laws. It can now finally go out to the destination or to the customer. Now you can imagine at that stage, this person is usually the one who knows the most about these laws, and they look at it and say, no, it's not ready yet, and it goes back. And this goes back and forth. It's almost like ping pong. And it costs time and it costs a lot of money. It's incredibly inefficient. It's probably one of the most inefficient processes in pharma. So Hank and I thought, there must be a better way than this. Because when you distill it down to what it is, it's really two things. It's a knowledge problem, as in people need to understand what they can and can't do. And on the other hand, it's a checklist problem, because you need to know where do you apply these laws, and what circumstances, and what materials, and what contexts. So we thought, we can solve this, because we've got a really, really extensive domain knowledge. So we know this area inside out. We have felt the pain of this process for many, many years. But also, we know what a good solution could look like. And as I mentioned, we're massive AI enthusiasts. And we've made huge progress in our understanding of LLMs in our prompt engineering. Just to give you an example, we started off pretty good, trying to create a picture of what we could look like as two tech entrepreneurs. But as we got better and better, we're getting quite impressed with ourselves, and to the point where we're like, hey, this is actually pretty good. we're pretty capable. But we put this knowledge together, working with OTS, and we actually created an auto review engine. So this is a system where the teams can upload their documents to. It'll review those documents based on the laws and the codes, and it'll flag up any risk or compliance risk to that material, enabling this pathway to be much, much faster, much more time efficient. And the beauty of this software is that it can be done in real time. So we don't have to wait for a reviewer to be ready to look at the document. They can just upload the document straight away and get an answer. They can do it as many times as they want. Also, it's consistent and objective. So one of the issues with reviewing materials is that you have different reviewers. They've all got their different biases. They've worked in different companies. They've got different risk levels. That can be a problem. But when you've got an objective system which just looks at the facts every time the same way, now you've got a common way to look at the law, and actually you remove that friction. You actually have teams who come together and say, well, what the risks were flagged up? And they can have an open discussion about how they get over it rather than having this frictional relationship. And also, these laws can change. Not very often, but they do change, probably every 3 to 4 years. That often takes training for teams to understand what this means for materials, how this actually happens in practice. With this system, you can update it the next day, and it's ready to review materials with the new laws and the new codes. Many, many benefits to this type of software, but the biggest two benefits are it saves money and it saves time. And it means companies can be more competitive because they can get their materials out faster, they can generate more materials, and also those teams who review these materials have more time to do other things, better things within their company. So how do we do it? How did two non-tech bros manage to build this software with no technical knowledge whatsoever? Well, we really had to build a bridge, really, between our domain knowledge, so what we bring to the table, which is our deep understanding of the laws and regulations, and the logic rules, like how do you apply this stuff? And then the technical team had to look at that and say, okay, what's the right tech stack? How do we build this infrastructure? And also, how do we embed the AI into this tool? And this is known as domain-driven design. And it's actually really difficult to do because you're trying to get these two things to work really nicely. So to kind of paint a picture of how difficult this can be, does anyone know what this scene's from? I've kind of given it away. Squid Games. Who's seen the Squid Games? So quite a few people. So for those that haven't seen it, it's a show on Netflix where a bunch of contestants are doing different challenges to win some money, and they're quite gruesome challenges. And this one challenge in particular is a glass bridge, and you've got a left step and a right step. One step is a very sturdy bit of glass that will not break, and the other step is a piece of glass that will break. This is a bit like this process. You've got to be really careful. You don't get many chances before it's game over. And it's a bit like how you cross these two domains. The first one is you have to have a common language between the domain experts and the developers. Because this point in time, if you don't get that right, you're building one thing and thinking another thing, and the two things don't work. And you don't have a way to communicate that deep knowledge to the way that the tech developers can actually put into practice. The other part of this process is that this domain knowledge can often be really, really complex and have really abstract logic rules that don't really make sense to those who are not in that area. So how do you make that communication right? And also, how do you make sure that in the future you can scale it? So if anything changes, you can change those rules without getting really confused about which part of the software does what. And then finally, once you've managed to overcome those two steps, how do you actually pull this into an app and make it work reliably at scale, enterprise level as a full-on SaaS software? Well, this would have been really, really hard without no-code tools. And there's one in particular that we've used trying to overcome these hurdles. And to tell you all about that, I'm going to get Hank to kind of go through what we've been able to do. Hank.
So as true tech enthusiasts, what's the first thing we do? We go on the internet, we Google, what tool do we use? And of course, we did the clever thing. We went through all of them. How many of you would believe that? None of you. Of course we didn't. We're non-tech people. We don't understand. I didn't even know what no-code tools were 2 months ago. So nope. So hands up or shout out, if you've ever worked with corporate people or non-tech people in maybe finance, what do they use? And this came up before in one of the talks. Absolutely, let's give Excel another jab. So that's the first thing we tried, right? So me and Will sat down, first week of development, working with LTS, kind of like, let's put everything we know into Excel. Let's create 10 workbooks, each with 20 tabs, and let's connect them. 3 days later, we're like, we can't do this. This is a miserable fail. So it's a no-go. And what did we do? Actually, Fibery came along. So actually, it was by pure coincidence we ended up using Fibery. So one of Anton, who works with us, suggested, hey, why don't you track your logs, your dev tasks, and your various meeting stuff in Fibery? And we're like, oh, great, let's give it a go. And we used it every day. And over time, we're kind of like, hey, we can do this in Fibery because it's got this really powerful relational database feature. So we found it to be the perfect tool for domain experts to build domain-driven projects using primarily these relational databases. And that solves 3 of the challenges that Will mentioned earlier, which is establishing a common language, define really complex relationship which domain experts rely on to make business decisions, and then finally implement these business logic into the application logic. So for those, you've seen this before actually, it was a, promise this was not a setup between Fibery and us, it was pure coincidence. This is a map of all the databases that we currently have in our Fibery workspace. Each of those colored blocks is like it's a database. And well, we use Fibery for everything. You can see there's a workspace on the top left for client relations. We've got business insights we track. We've got roadmaps we're actually documenting in Fibery. And those individual colored blocks are connected by relationships, as the Fibery team showed earlier. And it is in this prompt engineering workspace where we have all of these databases representing different knowledge contexts, which we leverage to help to devise and develop our business logic. And let's dive into looking at how these relationships and these databases help to solve our challenges. So establishing a common language. So Fibery provides a ready-to-use UI and a platform for us, Will and I, to kind of just go straight in and input data into these databases. Each database, we give it a very specific context. So it could be a database about products, or it could be a database about product information or safety information or laws or regulation. There's a database for prompt. And within these databases, we have entities, so items or records that defines, what a list of products. What are they? They all have different fields. They represent properties. And for each database and for each entity, we're able to create different fields of
different data types that defines that entity. And that flexibility, which the team mentioned earlier, is the, for us, the superpower with Fibery. We're able to really be really flexible in what we build to mimic the real world, variety of business situations or business entity to business definitions. And it is through those that all of our sort of subsequent business logic are built upon. So next, we looked at defining complex relationships. So again, Fibery gave us the tools to directly go into the database and start and connect different fields across different databases. Again, it supports one-to-many relationships, one-to-one, many-to-many, and you can also do lookup. These kind of really handy features essentially does all of the heavy lifting when it comes to us creating the business logics. Just as an example of the different contexts that we have in our space is, as a we're building product for pharmaceutical companies. We have context around pharmaceutical laws, product information, safety information, regulatory data, company info, and by allowing the relevant information in each database to be put into the prompts or put into the different business logic as and when needed, that allow us to replicate what a domain expert do when it comes to making decisions. The best thing is no custom tooling is required, which saves time for the developers, which saves time from a lot of the communication, all the miscommunication that could happen if you don't have a tool like this. So building on top of that relationship, it allows us to iterate quite quickly. As Will mentioned, these business logic change over time. And as we work through a lot of these test materials, real life examples of decision needs to be made, we discover fringe cases or fringe business logic that we couldn't account for in our model. But with Fibery, it's so easy to define relationship, and those relationship between databases are all automatically updated, synchronized in real time. It allows us to really pivot and iterate into really difficult business logics, whereby now we're making an assessment on a material or a piece of law based on a number of conditional parameters. And this is just one example. This is 1 out of 154 law clauses that we're working on. And can you imagine without something like Fibery, how would we ever try to communicate with the developers about something like this? Have you anybody seen the film Inception? Dreams within dreams, within dreams, within dreams. It is a little bit like that. Even the expert themselves, as they follow their business logic, if they're very difficult to track, and think about the number of potential scenarios you could come across. So Fibery, the way in which Fibery is allowing us to do is, to think very transparently, allowing the whole development team to see the business logic, to see the definition, and work together much more effectively. And finally, another usage case that we've got in Fibery is that we build our testing loop right or in the Fibery sort of UI. So we actually host all of our test materials in Fibery. And test materials are essentially mock documents that we know contains problems, that breaks the law. And because we know what law it breaks, we know what flags our system should show up as we pass the document through the system. So those are like our expected results. Again, within Fibery, we house all of the business logic via relational databases. And with some help from our developers, we're able to set up a way in which, by just clicking a button in GitHub Actions, we're able to test a batch of test materials that's housed in Fibery, and then it'll generate the actual results from those test material. We're then able to compare the expected results, evaluate the performance of our business logic, and use that to improve our business logic. And so we do that continuously as we're building more material, we run more tests, building material, run more tests, and improve. So we thought that was quite cool, which is different from what I guess Fibery was initially created for. And finally, the final ingredient really is, all these business logic that is put into the database by me and Will needs to be taken into the application layer to be written in code so that the application behaves the way it should do. And the API allows that to happen. So our developers is able to pour all of the business logic as the way we intended and as the way they were written into the backend and turn them into the code that is needed. So that really helped us in terms of development. So thank you. Pass back to Will.
So bringing it back to our analogy of the bridge at the start, we've managed to scale the bridge and get to the end because of using this no-code tool. But, because many startups have failed because they just can't get past those barriers. Startups are on a short timeline, right? You've got a little bit of finance, a little bit of runway, and if you don't make it in time and have too many friction points in between, you're just not going to make it. But this no-code tool, Fibery, has really helped us accelerate our thinking, really transplant that kind of business logic and domain expert knowledge into something we can actually use, refine, and scale, and change over time. So we think it really represents a really cool time to be working with AI because there's so many old problems to be fixed now with AI. And with these tools, you can now bring domain experts together with tech developers and create some really, really cool stuff. We're not sponsored by Fibery, by the way, but I think we should definitely get a free subscription after that presentation. But no, that obviously it's one of many tools that people can use now, but we just find Fibery to be really good for our use case, particularly trying to work out, well what does this mean in terms of have a checklist and how is it working from a database perspective? But yeah, as Athena, we're going to leverage this tool, leverage these no-code tools to create more and more systems. But for now, we've been super impressed and it's been a really, really fun journey. And I don't think without these types of tools, we could have brought this idea into conception. But hopefully that's inspired a few of you to think differently about, how to work with non-tech developers and the opportunities out there. And it'd be great to speak to many of you at the after party. Thanks so much.
Any questions, obviously, we've got time.
Non-tech questions, by the way. Someone at the back.
There's a mic here. I don't know if it works.
Hi, thank you for an exciting presentation. The question is, do you have to go through any formal accreditation so that pharma companies could use you as an agent?
Sorry, I didn't catch the first part of the question.
From my understanding, pharmaceutical industry is all about compliance and standards, right? And do you need to provide any, I don't know, proof that you are reliable, that and then you understand.
Absolutely, I get what you're saying. So I guess it comes back to the privacy bit, which we were talking at the very start in the first few presentations. Absolutely critical. Privacy is huge for this industry, but also these documents are confidential until they're released. So it's really important this stuff doesn't get released early or it's not stored in some server. So obviously we use various ways to kind of make sure that we can keep it private. Obviously, we're not using the open enterprise versions of ChatGPT. We're using it through Azure, but we're trying to sort of look at ways in which to reduce that kind of any leakage or whatnot. That's a very non-technical way of explaining it. But this is a big challenge for the industry, and they're quite shy about using AI tools because they're worried about privacy. So some are moving to their own models, internal models, and others are looking at the compliance really carefully. So for any kind of AI product in this space, you really have to make sure that you can really explain what the privacy aspects of it are.
I heard a different question, which is about whether we needed any kind of accreditation for our application to be used in real. Yes. So so on that, if there was a schematic on one of the slides where it showed there were different people involved in the process. So our AI software does not replace the medical signatory or the final approver. Not at this moment in time. We're still very early days. Some of these checks still, there are different levels of or different levels of risks involved in a document. Some risks are simply you can't say the word new. That's really black and white. But there are some risks that are slightly harder to grade. For example, it's a gray area, like For example, is this claim misleading? You know, maybe the evidence from a clinical trial is inconclusive, and therefore, you know, what this statement is not technically false, but is you're pushing it. So those are a different kind of decision that is, you know, slightly grayer in determination. So there are some, I think, at this initial stage, especially so early in the sort of adoption of AI in pharma companies, I think they will be happy to delegate some decisions to AI, but there will be some decisions they are currently not comfortable to delegate that. But over time, as AI improves, accuracy improves, I think we'll eventually get to a point where, you know, even without accreditation, you know, we have the faith in the software. But at the moment, you know, we don't need accreditation because a human person is still doing that final sign-off. We're essentially offloading a lot of the tedious, repetitive work of shedding that off the process.
Yeah, thank you. My name is Andrew. Thank you for this inspiring speech. I have a question about slightly about different location, because I'm initially from geospatial. As I understood, you're focusing especially on UK as a location. Did you try to use your model for any different location like USA or European Union, even without hard modification? How successful it was if you tried?
So we haven't tried it yet. We focused on the UK because that's the bit that we know the best. So we thought, let's start there because that's where we're experts in. However, I would say the UK laws are quite stringent. In fact, they're probably one of the most difficult, I think, of most countries. So we also kind of thought, well, if we can do it really well there, then it should be easy to scale in other countries. Europe has a very similar type of law. It's just not enforced as much as the UK. And the US is quite different because they can market their products to the public as well as healthcare professionals. So there is ways that we can tweak the system to accommodate for that. You're absolutely right. It'd be more of a paring down of what we're doing at the moment because their laws are a bit more flexible. And also there's some different laws in different countries that don't come in the UK. But there's absolutely the ability to do that. And that's definitely in our pipeline.
Okay, thank you.
I think there are many different ways to implement what we're doing. I think it's about trial and error, like any kind of development work, right? To figure out what is the most effective way. And I think, you know, once we learned what works well in this kind of approach, we can then look at what other different kind of approach will work even better. And, you know, different contexts of laws and different kind of database structure might detect that approach. Yeah.
Okay, thank you. Maybe one other question from my side. You cannot answer if you don't want, but did you make some estimation how your AI engine support and how it reduced the cost of final process from the initial prototype to final approved practice? How much it reduced cost? How much it reduced time spent for all this process?
It's a really good question. Something we're working on at the moment, because the first kind of prototype was just kind of like, the first idea is let's make it work. Doesn't matter how much it costs, let's just make it work. And then after that, we'll make it more efficient. So I think the first run we did was like, I think it was nearly like $20 or something. And this is just like one document. And you can imagine that at scale, it's quite a lot. And that was for one law out of the 157 or 54 laws. So this can really add up. So we are now at the minute of making it way more efficient. But the first principle was to make sure, can this work first? And then once we know it works, let's try and pare down, reduce the API calls, make it a bit more efficient in what it does.
Again, I heard a different question. You asked me how much we improve.
This is why we make a good team.
I heard how much our software improves the process. Shedding review time, reducing cycles, and so on and so forth. That is something that we're collecting right now, working with our partners. So we have got agreement with a number of partners at the moment, and it's a launch program where they get early access to the software. And it is in this program we hope to collate some of that data and how much improvement in terms of like commercial gain a return that they can get back from our software. But we heard from one of the reports estimating the impact of AI in pharmaceutical industry. It was a report by McKinsey, I think earlier this year. Generative AI in this space is able to increase the increase the productivity level. I don't know how they measured it, 2 to 3 times. So take that however you will, and you can read the report. Actually, it's a AI in pharmaceutical industry, McKinsey report. So it talks a little bit about that. So let's hope that happens.
Yeah. Sorry, yeah, I have a small question based on actually real case study in Poland. So let's begin with a question. I assume that, if I correctly understood you, your tool only gives back red flags, which laws could be violated, and in what way. No more information. Like, this is what I'm asking. Like, spectrum of probable financial consequences. Like, if you do this, it might result with 5% probability with high fine in millions, but most probably we will pay a fixed price of 50,000. And in fact, it was I mean, I don't know if I'm pitching you some kind of feature, but especially in this country, it is a real case study, because my friend was designing a media campaign for a pharmaceutical company. And on that stage, all of those accepting parties said, no, it won't fly, it won't fly. Everyone on the ladder said it won't fly. However, my colleague was persistent, and he knew CEO, and he showed it to the CEO, and CEO evaluated it, and basically, okay, they didn't sign it because it would violate the law. Yeah, that was the red flag, and in your case, it would be stopped and reiterated. However, the fine was fixed to 50,000 zlotys, and gains were in 7 numbers. So the CEO said, fuck it, yeah, beep it. So they went with it, they earned money. So in this case, if you would show probable and possible financial fees, especially when they're fixed, come on, it's a no-brainer.
I'll definitely have heard the wrong question, so I'm going to let Hank answer first.
The question is, do you even think about this kind of feature?
Yes. That was the feature. No, but really interesting. Actually, there are lots of features being planned, and that is not one of them. So if you do see it as one of the features in our software, then you can, we'll credit you. But that is a potential use case that will be very appealing to customers. But I think what's interesting is the consequences of violating the laws that we are working with is a little bit hard to predict, because the decision as to what happens when you break that law depends on many factors. It is almost, in my where we can possibly be better than this, it's almost impossible to put a fix. I mean, if it's something quite, harmless,
just to be clear,
okay.
We wouldn't add that in. I mean, from an ethical perspective, we would never add something like that in, because because I mean, look, this whole industry, the whole idea is to protect patients at the end of the day. This is why these compliance laws are there, to make sure that we're not doing things we shouldn't do. When you guys get your medications, you get the right ones. Doctors aren't misinformed about why you're having them. This is why these laws exist. So we wouldn't necessarily include that. But in terms of, for those areas where at the minute where LLMs can't give you the definitive yes or no, for sure, we're adding in a risk of probability in terms of how risky is this statement, and why is that risky, and what do you need to think about before you move forward. Ultimately, the final signatory, so the person at the end of that trajectory, they would basically have the final say of, yes, this is okay or not. But the AI is there beforehand just to kind of help you understand where the potential breaches are and risks are, and give you a bit of a sense of how far in terms of that risk level it could be, so you can make an informed decision. But from the finance perspective, we wouldn't really look at that. That's because The reality is, in the UK, there's quite heavy fines for breaking the laws, but there's more kind of I guess it's frowned upon in the industry, and when this happens, other companies look at other companies and say, what are you doing? It's not really why we do what we do. We do what we do, try and treat patients better, do a better thing, and play by the rules. So we just want to make sure, just to clarify, that we're doing the right thing. But the risk level, absolutely, because that helps inform decisions what happens further down the tree in terms of how risky is this statement.
Thanks a lot, guys. Thanks a lot. I'm sorry. Yeah, I know I'm the party pooper here, ruining all the opportunities to ask questions. But as we need to stick to the time and leave the place before 10. Thanks a lot, Athena. And I'd like to invite on the stage next guys who has built the first GPT radio in Belarusian. And let's welcome them. And while they are, let's welcome.
Hello. While we're waiting, I would like to do a little trick for your mind, so it's going to be more attentive, because as we all know by Pomodoro technique, that it's only like 25 minutes that our mind could be focused on something particular. So we have a couple of minutes. I promise you that it's going to be pleasure and fun. I ask you to stand up. It's going to take 1 minute. It's going to be fun and pleasure. So I want you to turn right to your neighbor. Turn right. Right is here. Yeah. In a mirror. Put the right hand on the shoulder of a person in front of you. You can stay closer to. Okay. Put the left hand on the shoulder of a person in front of you, and massage that person. Massage, so it's gonna be nice and pleasure. Nice and pleasure. I see that when it's a girl and a boy, it's working quite good. All right, wait. Only one person receive massage, so turn around. Turn around. Everybody deserves a pleasure. And massage a person the other direction. All right. Now your brain have some fun. It's active again. And we can start our presentation. All right, how do we switch? Thank you. All right, so we're gonna present to you our story. How do we create a GPT radio that speaks in Belarusian language? It was created by me, Dennis, and 2 other guys. And on the path on that, it was some easy and hard steps for us, and we're going to share it with you.
By telling this story, we want to share with you an idea on how to check your idea for startup quickly, especially in field of AI. We think that in this field, like AI itself, it seems like a great technology, but it's a technology that's looking for a problem. And many people have ideas, they want to test them, focus on them, but we want to show you how you can test them quickly without spending a fortune on it, and quickly get to know, is this idea valid and worth pursuing forward?
Yes, so we have a little agenda here. So at first, we're going to define what was the idea. Then we'll tell you a story. How do we form a team? How do we decide what to do as MVP, minimum viable product? Then the implementation part that Dennis will share with you. Then the part, how do we go to market quickly to get a feedback? Then how do we analyze this data, and what decision did we made at the end? So without further ado, let's go to defining an idea. An idea was very simple: to create a radio that costs almost zero to promote Belarusian language and culture. because many of us are living in exile, and to create such a media, it costs money. And if it's cost almost zero, so it could like support itself. That was the idea.
And this idea had some time. It didn't start it right off the bat. George actually came up with it like 2 years ago, tracking when ChatGPT was first released. And technology just wasn't there. There was no TTS model to build upon that speaks Belarusian language quite well, so he waited for it. And even now, like, technology seems to arrive, something is available. The first thing he did is he went ahead and find a team. And to find a team, you want to be in an environment where you are likely to find like-minded people. So in our case, it was Krakow Business Club, and it was organized by a Belarusian organization. So you're likely to find people who know what your language is, what your problems are, and share your idea with you. So here we met 3 of us, George, Vanya, me, Dennis, and all 3 of us were interested, and we started building from there.
Yes, and what I want to add that some people, they try to keep their idea to themselves, afraid that it's going to be stolen by other people. But the reality is that it's very hard to persuade somebody to do what you want to do. So as more people get involved into your idea and to share your idea, the better chance you have to make it real. The 3 of us started. We decided what the project would look like, and then we searched for the backend specialist that would do like some backend job for us. And we found Dima, and this is his story. He asked me to read it. So one day, a regular Krakow's IT man was sitting in a trivial Telegram chat and doing nothing. Suddenly, he saw the question of George. Is there anyone who wants to join a startup and help with the backend? This guy was absolutely no backend guru, just had some curiosity and decided, why not? That was the price that he was working for us.
Yeah, specifically asked to read it in this kind of style, you know.
Yeah. That it would be like a presentation of a new voice model of OpenAI.
Yeah, but we did it on purpose. We wanted to show you how it can look like for a person who don't know you. It was actually his reaction on a social media post of George, and George just shared it openly. And Dimitri, he reacted. It was interesting for him, and he actually did quite a ton of work on this project. So it's just an example of how you can get a fresh mind, another pair of hands on your project just by sharing it openly. Don't hesitate.
All right, then we need to decide what would be a minimal viable product, as minimal as possible. And we decided on these 5 things: that we prepare text by manual LLM prompting, no automation apart from like simple scripts. We prepare voices by manual input to text-to-speech models. We create only 2 hours of radio air and repeat it on loop, so we wouldn't work with heavy files transferred to each other and increase the load. We also create forms to gather a feedback from users, so we would know how to improve our service from the users, not from our own ideas. And also the most important part, that we use Google Analytics out of the box, that it's easy to implement, and we know for sure how our users using our product.
And we went on implementing it. So first idea was to not host any music at all, just use third-party streaming services API, only serve host speech, and have some console to make a playlist, something like that, have simplistic front end. So that sounded like a good idea, and we went on searching for actual AI models. What we did is we simply gathered together in a tea house, drinking tea, getting to know each other better. And okay, what do we need to do? We need to find LLM that can speak Belarusian language. Go ahead and search it. We searched 3 of us together. Seems like very easy to find it. Even ChatGPT speaks quite well in Belarusian nowadays. So we didn't spend much time on it. Big ChatGPT, go forward. But with TTS, text-to-speech, it was much more complicated. A lot of them, if not majority, speak like with heavy influence of other language. It's such a heavy accent, it's barely can be recognized as Belarusian.
It's either like lost tourists from United States in Belarus trying to find a path, or like a Polish guy who drink too much beer and like trying to speak Belarusian.
Yeah, Polish, Ukrainian, English, all over the place, but not Belarusian accent. And then finally, we found a project called Donor.by. Shout out to these guys. They are doing an amazing job. They are collecting pieces of audio, people specifically can record how they read sentence and then can read and approve it. And they collect a big database of these sentences to teach LLM. And they actually prepared a model, which is Bell TTS, open sourced. We picked it, we liked it, and we decided to run with it in the beginning.
Yeah, so then we need to decide on initial front end, and we were arguing our job was to reduce as much functionality as we can. In the first attempt, we decided that we would give a form for people who would like to advertise on our radio, how to monetize, and also we would give the button to make a donation. But we didn't plan to connect a payment gateway because it's hard, it takes time. We wanted just to see how many people would click on a donation, so we would understand how many people would like to donate, and by that understand whether or not it's viable.
And for the backend, we then figured that using third-party API doesn't really work very well, especially for SoundCloud. They disabled the API service, and we needed to serve hosts speech anyway, so we went for some Caster FM, like a free tier solution for MVP up to 100 listeners, and we built this backend architecture. Dimitri was in charge of that, and he did quite a good job, and he did a lot more later, but this was enough for us to have some working version.
Yeah, so we get the working version in like 2 weeks, and we get back each 2 weeks, there was a meeting of this Krakow Business Club, and we get back to this Krakow Business Club and say, hey guys, do you remember like last meeting that we shared this idea? Here's some product that you can use. And we get the feedback from them in a real time. They open it, some of them didn't open it, so it was buggy. Some of them say like, hey, I can understand that this is a robotic voice, but most of the feedback was positive. People were curious and like, wow, this is really like can be done, and that gives us like a positive feedback, and we continue.
Yeah, we decided to make one more refinement loop, at least to make it work, right, before we make a big public release. And the first thing we wanted to improve is the voice of our TTS model. The one from Donor.by, while good, it was lacking intonation. It was much robotic. So we just reached out to them, and they actually just shared with us their data set. Just go ahead, train your own. And we did something, but it wasn't enough. Like, we couldn't beat them. We didn't have time to do that. We wanted to be quick. So we actually dropped this idea. We moved on, but we will come back to this later.
Yeah, so the new UI feedback, we get rid of the advertisement and donation because of the rights to the music. People start asking you, what are you doing with the rights with the music? And we understand, oh yeah, we need to ask this artist permission, and we ask, I manually write to the artist. Some of them say, yeah, of course. Some of them said, oh no, like it's better not to show my music on this. So we need to redo this 2-hour air on radio. And also we get to know that if you do not supposed to earn some money and you transmit this music, so most of the people wouldn't care. So we decided to get rid of the monetization for now and see what the analytics do we get releasing it for free and with this functionality. What do we add? We add additional forms so that people would share their ideas and feedback.
And we redid backend a few times. We needed to scale it to support a few thousand listeners at least. And we tried a few solutions. Like there was a relay to stream, didn't work quite well. There was AzureCast, like big solution that's supposed to solve all the problems. It didn't for us.
Wasn't good at all. Like Dima was not happy at all with AzureCast.
Worked quite terribly, yeah. And then we landed at this. This is something that worked. Just on the standard server, was able to support a few thousand people. So we were happy with that. If you want to know more technical details, you'll have our contacts in the end of this talk. And if you happen to want to build a radio, Dima will tell a lot for you. Yeah, and this is a slide that we wanted to show you. Like you imagine radio, you want to have it fully automated. So you have a playlist and then the host takes information from news article, from calendar, makes up interesting story all on the fly, sends it to TTS. TTS voices it over, sends it to the live stream, and that would be a dream radio, wasn't it? But it's quite complex. And we, from the beginning, decided that our target is to prove an idea, to check if it's valid or not. And we intentionally didn't build this one.
Yeah, because to build this one, you need a lot of time and resources, and we didn't have but don't want to spend it. So here is the two examples.
Yeah, we have two examples of the voices. If I can turn them on.
Yeah, so the first one was from Donor Buy. Yeah. Yeah, no.
Let's see if I can turn them on.
Okay. Is it a Google Slides or is it PDF?
Yeah,
should work. All right. We can prepare for that in case. Too many people write to me after you did.
Well,
okay.
Maybe we just let people to listen to our radio afterwards. What do you think?
We want to show the difference, what was before and after.
Yeah, so generally, just a week before the release, somebody write to us on social media like, "Hi, I heard your radio, I heard your voice, and it sounds kind of robotic. Do you know that OpenAI just like a week ago released advanced voice mode that can do better in Belarusian language?" And we're like, "What?" And we checked it, and it actually does. And maybe we have a chance to listen together now.
So it's not from my it's not from me. It's from the presentation. Oh, okay. So this voice is a voice from Donor Buy, and it cost us nothing to generate that. And we also have the insider information that they are gathering more data, and soon they will be able to release better quality model. But we needed to wait like a few months, and we didn't want to wait a few months. And while I was sharing about this project, somebody came to us and say, "Hey, listen, like the OpenAI, they did this release. Like, why don't you check it out?" And
can we just turn on the second audio file now? That would be sampled from OpenAI.
The anticipation. As you can hear, Yeah, thanks.
Oh, that's enough. That's enough. Thank you.
So as you no, yeah, that was our reaction as well. So no accent, and it's soft. It's a pleasure to listen.
Yeah, so I was flying on like a trip for work, and we last minute got this info. I was in charge of AI stuff in this project, so I just revoiced this entire playlist of 2 hours in the airport, like coding some Python a little bit, and we got to the actual release with the new voice.
Yes, and then we have a fully functional MVP that could support like a few thousand listeners, and we needed to go to market. And before we even started the project, I wrote to mass media and asked them, hey guys, would you be interested to write about first ever built GPT radio on Belarusian language? And a lot of them say yes. And I encourage you to, when you speak with mass media, use this first ever. This is a hook that hooks them to write about you for free. So we get published in a few media like CityDog, Nasha Niva, DevBuy, and also Euro Radio, which were a little bit afraid. Like the reporter, the journalist asked me, "Are you going to replace us? Like, what's going on?" And we said, "No, guys, you are doing a good job. It's hard to replace you."
Yeah, and this is how it looked like when we released. It still looks like this today. You can go to gptradio.online, make sure to make it HTTPS, then it will work on mobile as well. And yeah, it just worked. We made a simple UI, we made a simple backend, and 2 hours of podcast.
Yeah, and if you speak English, you also can listen because there is an English version as well. You can just need to switch.
Upper right corner.
Yeah.
Yeah, just because it's easy to do LLM in English, it's just 5-minute task.
So it's just about Russian music with English host.
Yeah, and we gathered some feedback. Feedback was mostly positive. Some feature requests, some just general comments. People loved it, seemingly, from the feedback. But what we wanted to look at, the actual usage, because this tells us more about how this product is actually being used.
And so we come to a point where we need to analyze data. Like what does it say to us? Like how does people use it? And this is the data from the usage. You can see 2 spikes. Yeah, that were the release of the articles in mass media was. And unfortunately, the key metric is 38 seconds. 38 seconds of average listening of this radio. So as you understand, the assumption is failed because it's supposed to be the radio that people listen on the background in the kitchen and get to learn Belarusian language and get to learn new musicians. It didn't. People don't listen radio on browser anymore. But there is some side benefits that we get by doing this project. First, we get real experience on working with these models. We now understand how to connect them, what's could be challenges in working with them. Second, we get to know each other while we were working, and right now we have a team that could be like used on another project. And third, while we were doing, a lot of people get involved and get excited. So there is many connections that were formed during this project. And to understand how much does it cost to us, it cost less than $50 for the whole team and less than a month of our time, which was fun. So this is the side benefits that I hope would encourage you to do a project and to fail fast in case your assumption didn't work out.
Yeah, and to be clear, it wasn't like months of work full-time. We all have full-time jobs. We just gathered together on the weekend in a tea spot, and We also did some work in evenings. So it was not a lot of time and a lot of fun. These are links to our social media. Feel free to connect to us. If anybody is interested in how it works under the hood, wants to talk about AzureCast or other online radio with Dimitri, we feel like we will connect you. Feel free. And to be clear, our story is not universal recipe, right? Not a silver bullet. We cannot guarantee that if you fail fast, this is a way to move your project forward. But if our story helps you to get started, encourages you to start moving, and don't be afraid, share your idea, then it's great. We had fun. Now it's your turn. Thank you.
Wow, thanks. Yeah, so questions. Yep.
Thank you for the speech. Do you already has already extremist status in Belarus?
In Belarus.
Ah, okay. Yeah, it's actually part of the reason why Dmitry did not give us his picture because of that risk. But generally, no, like it went quite well. We didn't have any problems with that. And yeah.
They didn't capture us in 38 seconds.
Yeah. Too short.
Thank you for your speech or for your presentation. It was really interesting and inspiring. And my question is, why do you think people are not really interested in AI radio or AI radio in Belarusian? What do you think, guys?
I can give you my opinion. It might be that we picked a platform the wrong way, because having to open a browser, keep it open somewhere in the background might be a bit inconvenient. People don't used to it. If you go to listen music, you have a habit to go somewhere like a YouTube or maybe Telegram, something. And we picked an unusual platform. Maybe that was our mistake. So there was even an idea, a talk today, to just move this same project to Telegram, because everybody in Belarus has Telegram, and this might turn out with completely different result. But it might be as well something else.
I think that there is already existing solution that does not have an AI built in, like SoundCloud or the Euro Radio. They have this 3 radio stations that you can listen, depend on which one do you like. So I think there is no need for AI yet in this particular area in this time.
Go ahead.
And actually, I want to add something. If any of you would like to continue this journey, we would like to give you this project for free. If you feel that you can do something other than radio or something else, feel free to contact us. We are ready to give it for free. Okay, yeah.
1, 2.
Yeah.
Thank you guys for this presentation. And as I understand, this project is non-commercial. So do you plan to move your project to open source? I believe that there is many Belarusian people would like to help you with, I don't know, for starting from front end, back end, graphic, marketing, anything. What do you think?
And oh, thanks. Thank you for the question. I never done open source project, so I don't know how you do that. Maybe you can come and talk to us and explain how does it work, and if it's not a big investment of time, then maybe.
Okay, thank you. I believe that it's a good idea.
I believe it worth an invitation to the party.
Yeah, for sure. +1.
Hey guys, thank you for your presentation again. I just wanted to ask you, have you mentioned, like, have you tried to do the podcast type of radio? Have you mentioned that in the presentation somewhere? No.
No.
Have I missed it?
We actually did, but we didn't mention it, but we did try this, but only in English language because it's already available, like Notebook LM, something like this. Yeah, you just feed it information, it gives you the podcast. Not available in other languages just yet. So for Belarusian version, we have like a script that is supplying track before, track after, some supplementary information. You get a text, then this text gets voiced over by TTS. It would be perfect to have it in podcast format. It's just we are not there yet.
Yeah, well, I think we'll see like in half a year, maybe a year, if Notebook LM will, ship some other languages, and if Belarusian language will be available, I guess it will be a step up for your game, for real. Yeah, thanks.
And let's go with the last question, as we need to go to the party.
Okay, good evening. As a feedback, because I listened to the radio maybe for 4 hours, but then I got tired of the loop, and I would say that voice too sleepy because, you have to add some scandals, some intonations, some personality, because, and just don't stop, because I think this is a great future about this radio and about such radio stations. If you would be able to add some site information, some like subscription to API, to some sports news, weather forecasts, not political news, we have a lot of political radio stations, but business news, maybe some, and mix it together, it will go, it will fly. But for now, it's very short loop, and you just get tired, and you would not meant to listen whole evening for just this loop words or few songs.
Why did you listen to the end of the loop?
I listened twice at least.
Oh, yeah, why?
Why? Because it's just like music, and I just tried to find maybe there is some Belarusian song I didn't listen to before.
Why didn't you go to SoundCloud and just push a button with the Belarusian songs like best of 100 or something like that?
That is what I want to say, because of course I have a subscription for YouTube Music, but I need this voice in between, and I want to say that now this voice is too sleepy. It's just, and without some information, without some intonations, and you just put some humanity inside it,
All right. So maybe the Donor Buy will release a new model, so maybe it's gonna be better. And yeah, actually, initial idea, as you described, it would be a radio that you can push some information like news or weather. And also that the advertisers, they could come, they would put their input, and the models will create an ad for them and play this ad to the audience. And that's how this business could sustain itself. So that was the initial ideas. If we would get enough users listening, then we could do automation, and then this automation would lead to ads, and these ads would pay for the whole party.
Nice idea, but
guys, sorry, I have to stop it.
Yeah, let's go to the party and discuss it afterwards.
Let's have. I have a request for the last question, but promise me to keep it short.
This is not about question, maybe proposition to make it more alive and interesting for people. What do you think about to transform to speech most interesting and toxic speech from Twitter, from Belarusian Twitter?
I wonder how instead of asking questions, people start giving advices.
Yeah, it's still live. You can go and
go and work.
Fill the form. Okay, thank you guys for your attention. It was a pleasure to present you.
Hold on, guys, if you like any of questions, you can present the invitations to the party, and those who are going with us to the party, let's